Welcome everyone. A very good morning, good afternoon, or good evening. We do have a packed agenda today and excited to get going. We'll just wait for 1 or 2 more minutes for people joining in, and we will just begin in a couple of minutes. All right. In the interest of everyone's time, why don't we begin? And we will have a few minutes at the end for questions and answers. If you could just move on to the next slide. So I will give an introduction of the presenters for today's webinar on the next slide and a brief profile of the company, followed by the meat of today's agenda, which is SRE and why is it important. We will briefly discuss about some of the important principles of SRE and how it forms an essential pillar within the DevOps realm. We will also demonstrate 2 to 3 use cases focusing on reliability and maintainability of complex applications. We also hope to cover a couple of questions during our Q&A session. All right, so let's dive right in. So my name is Amit Gandhi, and I'm the co-founder and CTO for Parker Digital. I also have Jigar Shah, who leads the platform operations practice for Parker, along with Harshad Wagh, principal architect and practitioner of SRE. Now, a very quick intro about Parker Digital. We are now into our ninth year of operations, working with more than 90 enterprise customers across 10 different time zones. We have more than 300 cloud educated engineers with various specializations, many of them certified to work on multiple clouds. Now, almost all of our engagements fall into these five main verticals. On the left-hand side, we have the product management area, where we engage with many of our customers to do a detailed discovery or assessment of their needs, and then come out with a detailed product roadmap that includes engineering backlog and MVP, marketing, and go-to-market strategy, to name a few milestones. On the user experience side, we have a lot of experience in conducting UX assessments to understand the gaps and come out with recommendations on improving them with respect to industry leading benchmarks and setting new ones. This, more often than not, is an afterthought in the engineering implementation, but an extremely important aspect to drive your design and user experience. The next one is product development and pretty much our bread and butter in everything that we work on. This includes working on greenfield applications, modernizing or refactoring legacy applications, or migrating some of these on-prem workloads to the cloud. DevOps is an extremely important component of this, where we have automated provisioning of environments and release deployment pipelines using industry standard templates and frameworks. Now, once an application has moved to production, we do have 24 by 7 teams to monitor these apps. We have used standardized tools and platforms in our operations teams and have around the clock operations teams for network, operating systems, infrastructure, and application support. We have recently added a 24 by 7 SOC capability, extending the support for many of our critical customers. Finally, for data, Our teams have advanced capabilities in data analytics, both for product and end users. Be it Google Analytics or Adobe to get user information, or Azure Data Factory or Snowflake for data lakes and real-time data engineering. We have worked on many of these complex data use cases, and we will table it for another webinar for an in-depth discussion of the same. Next slide. Working on technology allows us to remain domain agnostic, but here are few of our amazing customers, and we have loved working across industry and on a variety of interesting problem statements. Some of our strategic partnerships include all of the leading cloud providers in AWS, Azure, GCP, as well as others on the application or tooling side in Red Hat or Zabbix, for example. Our platform operations teams has built some fantastic use cases on Zabbix and ELK, and our DevOps SRE practice has won a lot of accolades from our customers. Locations. Our offshore development head is in Pune, India, with Ahmedabad being the location for everything operations. We have recently opened a business in GCC and APAC regions, and North America continues to be the leading locations for our customers and most of our consultants. Here are a few of our achievements and compliances that we adhere to. We take data privacy very seriously and are compliant with HIPAA, ISO 9001, ISO 27001 standards, to name a few. With that, let me invite Jigar to talk about SRE principles and how resilient cloud infrastructure can be built and managed. Jigar?
Hey, thanks, Amit. Thank you so much. Hope my audio is fine. I just want to make sure that audio check is done before we get into SRE, because conferences and webinars and the Teams call is one place where SRE doesn't apply, right? So, hey, so we start with introduction to SRE, right? And the most important part to understand here is what exactly we mean by SRE. And there are two terms to it. One is SRE and second is SREs. And let's take an attempt to kind of define them. If I have to define SRE, what it means is site reliability engineering. And when we talk about that, site reliability engineering is an engineering discipline developed to helping organizations achieve their appropriate level of reliability in their system, services, and products. Now, here we give a lot of emphasis on two words. One is reliability. And when we talk about reliability, right, or when we're defining reliability, we are talking about reliability in terms of business, in terms of end consumer and customers, right? What level of services do we want to ensure that we are able to provide to end customer? And this always has a business in mind. This always has customers in mind. And when we say appropriate, right? Very simple statement is to make, I want 100% availability, right? But when we say we set mark as 100%, it's probably never the right target, right? You need to match the profile of your service to the risk business is willing to take, right? Because reaching 99 is simpler. Reaching 99.9 is a bit difficult but attainable. But when we talk about 99.9999, that requires a lot of engineering, that requires a lot of cost, that requires a lot of effort, right? So we need to make sure that we are striking the balance, and that's why there are different concepts like what is our error budget, which means how much failure ratio which we can accept from the business standpoint, and that's the SRE. And the team who is working on all of this, they are called SREs, right? Site reliability engineers. If I have to explain this to my daughter and say, okay, what are SREs? She might just say, okay, SREs are superheroes who are ensuring that city is safe and all the utilities are always available, always accessible, right? And that's what typically SREs do. They make sure that services are always available for end customers. Your SRE practice broadly fits in three areas. One is eliminating toil, which means whatever manual work we are doing, how do we eliminate that? And we'll kind of touch upon that a little bit into our subsequent slides. Also managing risk and handling failures. And when we look at SRE, there are a lot of there's always a discussion about what's the difference between SRE and DevOps. Are they not the same? Do we need to have both? Where do we start from, etc., etc. So if I have to kind of demystify, I would say if DevOps is a philosophy, then SRE is a prescriptive way of accomplishing that philosophy, right? So which both, I mean, both goes hand in hand. And that's the reason why you see like great alignment with like a top five areas of DevOps. If you look at DevOps, your top five areas of DevOps is we want to reduce organization silos, which means we want to bring in the operations team and the development team together. In DevOps, we want to accept failures as a normal. And when we say we want to accept failure as a normal, failure does not mean we have failed, right? It's where we learn it. And then in DevOps, we talk about implementing gradual changes. So if needed, we are able to fix them, roll back, we're able to do continuous integration, so on and so forth. Then we talk about, we leverage tooling and automation when we talk about DevOps. And in DevOps, we talk about, we want to measure everything, correct? Now, if I have to supersede with SRE framework or SRE principles on it, the way it would work is the first block where we say reduce organization silos. In SRE, we talk about shared ownership, right? Which means if there is a failure that, or if there is an incident, or if there is a system which needs to be set up, it has a shared ownership between the IT team, the developers, and different stakeholders within the organization, right? Who are also responsible for product engineering. When we talk about accept failure as a normal, SRE focuses a lot on SLOs and blameless postmortems, right? And when we say we have to accept the failures, right? Uh, we accept the failure, but at the same time, we also need to ensure that our production systems are not failing for this exact same reason again, right? Which means whenever we have a failure, it's very important to do the postmortem of that failure, identify what happened with that incident, what needs to be done to ensure that we don't have same failure again, right? And then we monitor kind of a mean time between the failure. So like my system has failed once, you have identified it, you do postmortem, you do the validation with SLOs, and you check that if your system is failing again, what is the mean time between two failures? We focus a lot on reducing the cost of failures, which means if there is a failure, right, can we bring services back online immediately, which means we are able to reduce our error budget. And that's how we can attain more SLOs and provide better SLIs. We reduce toil. And when we talk about we reduce toil, it's basically we reduce the effort on repetitive tasks, correct? Uh, and always like simplistic way, we also say if human operator needs to touch your system during normal operations, you have a bug, which means your system should keep running. If I have to, let's say, keep cleaning up the temporary space, if I have to keep recycling my web services to release the sessions from the database, that means it's a bug. We need to fix that. And any activity which you perform on day-to-day basis, a daily checklist, weekly checklist, monthly checklist, and those kind of activities, it's kind of a toil. We need to reduce it. A spoiler there is attending team meetings or setting up goals or filing up HR paperwork, which is again a routine activity. That's not called toil. That's a kind of an overhead, right? So, and overheads are out of the scope for SREs. And last but not least, when we talk about measuring everything from the SRE standpoint, we monitor the reliability of the system, correct? And there are different tools we use, and we make sure that we are able to monitor all the services. from the availability standpoint and from the service level identifier standpoint. So that's what we kind of look at it. It's crucial to understand that every system need not be part of SRE. Internal corporate application where we are, let's say, I'm just giving an example, and this depends on organization to organization. But the simple fact is, we don't need to have everything part of SRE, correct? So when we say SRE, it's crucial to understand that not every system will go through the SRE practice. If we have just an example, if you have an internal corporate application where you're allowed to submit your claims, where you look at the holiday calendar, where you look at the where you can manage your leaves, where you can look at internal organization memos, where you can look at internal organization updates and photos and those things. We might not need to consider that for an SRE, right? Because that will not have a direct business impact. And this varies from the organization to organization. So when we are starting our SRE journey, you need to identify the system for which reliability has direct impact on the business. And you need to identify what is the acceptable risk to determine your SLAs and SLOs for the specific services. Uh, Most of the time, you would have seen when we put SRE, the SRE activities breakdown, you will see the maximum time SRE team would spend on responding to outages, correct? And that's where the major portion of work goes on, and then followed by the post-mortem. So this two line put together has the highest focus from the SRE standpoint. And just to summarize this, there are a couple of things. Your SRE can coexist with ITIL framework. So maybe for your internal application, for your internal IT services, end user support services. Great example. I mean, you're not going to put SRE practice for IT end user support services where you help user with fixing printers, fixing their keyboards, mouse, Outlook related issues. I'm not able to fire a print job. I'm not getting emails. My Outlook is not working. I mean, for those kind of tickets, which is predominantly around end user services, service-based operations, you might not put SRE there, right? You will continue to deliver services using ITIL framework. But for within the same organization, for the services which are business facing, which are end consumers facing, you will implement SRE. So they both can coexist. It's not either or kind of an approach. And when you are implementing SRE or introducing SRE to the organization, you need to make sure that SREs, who are those superheroes, they must have time to make tomorrow better than today, which means they are able to spend sufficient amount of time on the postmortems. They're able to spend sufficient time on the learning systems so that they are able to bring in constant innovation. They're able to bring in constant improvement. With this, if we go to the next slide. Now, how do we grow SRE practices, right? There are different, I mean, the most important thing is when you want to grow SRE practices, first thing you will need, which is the core ingredient, is your SREs themselves. Now, your SREs can come from different places. They can come from IT operations side of it. They can come from product engineering side of it. They can come from application operations side of it. You can have SREs joining your team at different level from different like from different part of the organizations, right? It would mean that we're bringing a lot of cultural change in the organization, and one crucial parameter for that would be getting everyone on the same page and growing together, right? With the diverse skill set, with the diverse teams what we have. And that's where we utilize the SRE pyramid because we can start from anywhere, but like the ultimate goal is the having a product which is always available. And the reason why it's called pyramid is because every skill, right, it kind of builds on top of each other. So you basically start with monitoring where you are monitoring your logs, you're monitoring your events, you're monitoring your I mean where you have monitoring system, you're looking at the console, you have observability platform where you are looking at the alerts and everything. And that's where you start with the monitoring. I mean, that's the most fundamental block in the SRE journey, where you're able to monitor services for the reliability. And then from there, whatever alerts you receive, whatever errors you receive in the logs, whatever insight you receive from your observability platform, right, that will help you kind of work on the incident response, correct? Because when you have an incident, you should be able to drill it down further and say, what did I receive from my monitoring system, correct? And that's how it's like a kind of building on top of each other. So you are able to have better incident response because we are able to, from monitoring, you're able to get better insight. You're able to look at the logs more accurately. You're able to look at the thresholds more accurately and have, you're able to resolve incident in a faster manner. And once you have resolved the incident, right, you go to the next step, which is postmortem. Postmortem or root cause analysis. And this is where it has to be a kind of a blameless activity where you are drilling down on the incident, trying to identify what went wrong, what are the learnings out of it, what we could have done better, who all were involved. Your on-call team would come in. Did we send out communications appropriately or not? Did we get right information from the monitoring system within timely manner or not? So all of those things you combine together during the postmortem call and see that what needs to be fixed from the skill perspective, from the process perspective, from the tooling perspective, so that you are able to get better monitoring. And once you are able to do that, and once you're able to kind of bring in system into more reliable standpoint, it comes to the testing and release procedures, right? Because you're able to fix normal incident, but whenever there is a release, right, if you are able to detect code, which can lead into outage in production system, right, that will improve your availability, or that will improve your reliability a lot more. And then the next block, while it's labeled as a capacity planning, it's a more of a proactive approach, right? Which means when I'm designing my systems, I need to design it in a manner that any outage does not have cascade effect, right? Which means if I have clusters, and if there is a proper Kubernetes clusters, if I have that, I don't want one node failure to have impact on all other nodes available in the system, right? Which means I may have service degradation, but not service outage completely. And when we talk about capacity planning, it's a lot more about having that proactive approach, so that when you are releasing systems into production, you are able to restrict the cascade effect. You are able to restrict the regional spread of an outage, cross-region spread of an outage, right? And that's what we mean by capacity planning. And once you have kind of mastered that level, the next level where you work closely with the developers is on the development itself, where we say, when we are developing application or when we are doing platform engineering, can we look at principles of SRE and make sure that our applications are developed to handle resiliency, right? Or it's developed to provide better reliability. And that's where like all of this uh, breaking down the monolithic application architecture to microservices came in, where we are able to have better availability of the application itself. And that would lead us to the ultimate objective of having a product which is always available to customer and it's delivering best services. I mean, even if I have like most fancy feature and most exciting features available on application, if end user is not able to access that right when they need it, it's of no use, correct? I mean, imagine I have online booking application where you can book ticket for your best game, uh, and when you want to book it, if it's not available or if it's taking too long for you to book services, you're going to switch to the next provider because you want to make sure that you get your seats correctly. So that's what happens. And when you grow SRE practice, you will see the significant shift, right? Without SRE, you will see there is a very small investment done on the technical debt, which means you are cleaning up your legacy system, you are releasing your systems where you want to proactively do upgrades and all. Very less time spent on learning, lot of effort goes into unplanned work and very less time goes on to value creation. But as you grow SRE practices, you will see with SRE, you are able to spend a lot of time and your budget also on cleaning up technical debt. You're able to spend a lot more time on learning new technology, learning new tool set. You have very less time which you're spending on unplanned work, and you're spending a lot more time on value creation. So this is how you will be able to grow the SRE, and when you grow to the SRE model, you will see shift a significant change in the value creation itself. Uh, and with that, we can go to the next slide. And I would like to hand it over to Harsha to give a quick demo on SRE, and then we come back for the conclusion section. Yeah, so Harsha, over to you.
Yeah, thanks, Jigar. So, good evening, everyone, and thanks for joining. So, can we just go to the previous slide where I can give a brief description of what demos we are going to show? All right. So Jigar spoke about a lot of SRE best practices, right? And that's what we are going to demonstrate today. So as he said, right, toil reduction, then leveraging open source tools. You also need to focus on reducing the MTTR. So these are the three auto remediation use cases that we would be showcasing today. So those would be like short videos that I'll be walking you through, which we have recorded on our live environment. So the first one is end user impact, which is basically a swap slot automation. So whenever we are going doing deployments in the production environment, right, there is a high risk that a functionality might break, right? And then we might have to get on an major incident call or a swarm, look into the logs, right? Get a developer on the call, get approvals, and then we would like swap the slot back, right? So here, what we would demonstrate is like leveraging some of the open source tools and doing some anomaly detection via Grafana and Prometheus. We would be doing an auto swap slot. The second one is regarding load testing, which basically focuses on capacity planning. So that's a very important part of keeping your systems reliable and stable. They are very useful during business events, right? So when you're expecting high traffic on your websites, you should be ready with the resources that are required to handle that traffic. And the last one is regarding alert noise reduction. So this is an automation that we have built to test false positives. So as you must be aware, right, synthetic monitoring is like tracking the user actions on your website or on your web app. So how the user is logging in, he's accessing various links. So if there is any issue, right, or if you are on, let's say, a website which provides products or services which you can buy. So if there are any issues with the payment card or going through the workflow of purchasing a service, then it will throw an alert which will indicate that there's a failure which we need to look into. All right. So yeah, we can dive into the demo. And let me share my screen. All right, so I hope you are able to see my screen. Okay, so all the web apps, right, that we are going to showcase in these demos are built with our vector uh, reusable platform, right? So this is one of the wellness UI that we have built with our vector reusable format, like a platform that has various numerous UI templates, which will help you build your applications faster, right? You don't have to build anything from scratch. So this is the web application that we see right now, which has different categories of wellness options, right? The services that have been provided. And this this is like the front end is built in Angular, and we have APIs and gateways which are built in .NET Core and hosted on Azure App Service. So as you can see over here, we have them hosted as app service. So we are utilizing platform as a service in Azure. And then we are also using a slotting deployment, green blue deployment, which helps us deploy identical code in both the slots. And whenever we require, we can swap the slot, right? This is Grafana. So we are using Grafana and Prometheus as a monitoring and observability tool. So all the services that we saw right now, right? App services are being monitored over here. We are monitoring the response time, the status codes. We also have a dashboard for latency. And this is synthetic monitoring. Like we were speaking earlier, this measures the user actions, what is happening on the website when the user is coming and going through the various links or workflows on your website. Then we are using Bitbucket, which is like a version control system. So to maintain our projects, also we are using pipelines, Bitbucket, CI/CD pipelines to deploy the code to production or our staging and dev environments. All right, so we'll start with a demo where we would be deploying a new code to the production environment, right? So we'll run the pipeline, which will help us build the code. And then in the pipeline, we have a step which will swap the slot. And also we have a step where we have built an auto remediation script. So if we see failure after the deployment, Grafana will do anomaly detection, right? It will test if there is an increase in error rate or HTTP status codes which are not expected and synthetic failure. Then it will trigger this automation. So I just wanted to pause and also tell you that the reason that we have built this auto remediation script to be deployed during our deployments is because we want it to be enabled only during deployments when we see failures in the production environment. And it would be useful for us to do an auto swap slot, right? If we see failures. So when the script is deployed in production, we have this deployed on the virtual machine where it would be activated. And once the swap slot is done, it will be in a deactivated state. So we don't want it running in loop once we are done with the initial swap slot. All right, so yeah, we are deploying a new code to our master branch. So and then there's one more step which we will talk about in the pipeline that you can include is like a test case after the deployment is done, which will fetch details, let's say, from like a GET request if it's working as expected or not. All right, so this has been deployed, and we can also see that the auto remediation script, which we spoke about, has also been activated. So if we see over here, so Wellness API Gateway, that's the app that we ran the pipeline for, and the swap slot has been done successfully. So we'll check on so here we'll check on the website if anything has changed, right? So if you observe, right, the categories, we are not able to any longer see those styles, right? So this definitely is like a broken functionality that we are seeing in the production environment. after our deployment, right? So you'll see that the synthetic has picked up this failure, because if the user is trying and accessing that, he won't be able to see that, right? You're also seeing an increase in HTTP status error code, which is an indication that there's a failure, right? So here we are evaluating two conditions. One is the anomaly detection, which will show the HTTP status code, right? The increase in HTTP status code, and also the synthetic failure. So these are the two conditions that we are evaluating as a part of doing a swap slot. So now we also have to remember, right? Like sometimes there might be cases where you're doing deployment in production environments where there's a code or there's a functionality which will expect a certain error rate, right? So we can also use the feature flag on off if we don't want that pipeline to deploy that auto remediation script. All right. And that's the benefit of including in that pipeline. So yeah, we can see a clear indication of failure. So our response teams or monitoring team, incident response teams have been notified uh, that there has been a failure. And then we see that the automation has triggered and it has done an auto swap slot. So as soon as we saw a failure on Grafana on both HTTP status codes and the synthetic failure, the automation script triggered auto remediation script, which swapped the slot back to the original code. And now we are able to see these categories again. We'll also see that the error rate, like HTTP status codes, has gone down, right? And I think we should be able to also see the synthetic come up. Yep, so it's showing as green. So this is like a short demo that we were trying to showcase where what we can do is we can reduce that MTTR by leveraging some of the anomaly detection features in Grafana. Also our synthetic scripts, right? Which would be able to help us roll back like a bad code from the production environment. So here again, the teams are notified that it has been resolved, and even the synthetic check has come back with a pass result. All right, so that was like a short demo that we wanted to show you. So I'll move on to the next demo. So just give me a moment. Okay, so yeah, let me pause here. All right, so this second use case that we are demonstrating is regarding load testing. So we spoke about load testing, which is like an important activity of capacity planning, right? So it's important that we do proactive load testing on our resources, on our web applications. So here again, we would be leveraging the previous app, right? For our demo here. So yeah, I mean, this is again, we would be doing a load test on one of the gateway services. And here we would be able to see some key metrics on the wellness services app service when we simulate a load, right? So this is so here we are leveraging the app service or like auto scaling feature from Azure. So these all app services, right? Especially the wellness APIs and gateway and UI, they are on a shared service plan. And this is like a shared service plan auto scaling rule that we have set up for CPU percentage and memory percentage, and of course the socket outbound rule as well. So some of the features we mostly leverage from our own cloud environment, right? I mean, AWS and Azure have some features that we can leverage. So this is the dashboard, the auto scaling dashboard that we have built, which is showing the number of instances and the CPU utilization for this shared service plan. And we would be able to see a rise in the CPU or memory utilization as soon as we start putting load on the service, right? So here we can see the response time go up and the user request. So Blaze Meter is one of the tools by which you can perform those load tests. There is also Azure load testing and service within Azure that you can leverage. So here you can mention the total number of users, the duration, for how much time you want to put the load on your web application or resources, right? All right, so here we are seeing now the CPU utilization go above 75%, right? And then we should see the auto scaling feature kick in, right? And also the number of requests. So we are still seeing that it's on instance 1, right? The count of instances is 1. Here we can see that the number of requests are going up, right? Along with the response time as well. So yeah, if we see and here in the log activity, we should be able to see the auto scale feature been updated. All right, so the memory usage is also above the 70% threshold now. And here we can see that the auto scale is completed. So this tells us the number of user requests, right? So yeah, I mean, there's a alert that also goes out to our teams informing of the instances being scaled up. And here also we are able to see that it has jumped from 1 instance to 2 instances now. So yeah, I mean, this gives us a clear indication of how many user requests and at what response time is it scaling. And then if you're anticipating more traffic than that, right, for any business events, then we can do capacity planning ahead of time. All right, so as we see that the CPU and memory went down, the auto scale down event also triggered, and we are able to see that it has gone down to 1 instance now. And it should also trigger a notification to our teams. So this is more informational, right? Because we have the auto scaling rules already configured, right? So, but it's It's useful for our monitoring teams to know. All right, so let me just stop sharing again, and let me just quickly move on to the third use case. Just give me a moment. Let's share that again. Okay. All right. So here we will talk about noise reduction, right? I mean, the monitoring tool, the monitoring teams, right, keep getting alerts, right, from various synthetics or various alerts or thresholds that we have set. So it's important that they are also able to identify some of the false positives, right? So here we are using synthetics. So I like to speak a little about the robot synthetics that we are using. So they are built with Python, leveraging the Selenium automation PY test. And then we have health checks, which is also an open source scheduled task monitoring tool that uh, is listening for pings from the robot synthetic URLs. So in robot synthetic URLs, it will go through the various steps, a Python script which will do web scraping of how the user behaves on our website or web applications. So health checks would be sending a ping or a check to that URL to see if it's up or not. And if it doesn't get a ping, then it will throw an alert which will reflect on our synthetic dashboard in Grafana. So these are also open source tools that we are leveraging besides Grafana and Prometheus. So here, as you can see, that we have a notification policy that we have configured, which would trigger a script to check the false positive, right? So there are several reasons why the synthetic might fail, right? So the scripts that we have built or the health check tool that we are using, right? It can also face failures, right? I mean, our monitoring tools also need to be stable, right? If they are hosted on a container or a virtual machine, there might be chances when the script might not be working as expected, or maybe the health checks service is down, right? So that time it's important for a monitoring tool, like monitoring teams and tools, to indicate whether this is a true positive or a false positive. So here we can see that the synthetic is failing, right? And it has triggered an alert. But we also want to see whether this is a true positive or a false positive, right? So if we check the website, the tiles are working as expected. We are able to see that. And the same thing that the script, right? The automation script that we have built, it's a Selenium test automation again, which will scrape through the user flow on our website to see whether it's a true positive or a false positive. So it's important that we also are able to reduce the noise that is coming to our monitoring teams. We are able to deduplicate alerts, which will help them where they should focus, right? So here we can see, right, that the health checkup has come as pass. So although the synthetics is failing on the Grafana dashboard, this is not a true positive. This is a false positive. And then the monitoring teams can reach out to the SRE team who can fix this issue or the next level. So yeah, so these were the short demos that I wanted to leverage and showcase some of our monitoring tools, right? Open source monitoring tools that we have been using. So yeah, thank you so much for listening in and being patient. Thanks.
Hey, thanks, Harshad. And Rahul, if you can bring back the original slides for the closing remarks and conclusion. Yeah, so we saw a couple of, I mean, in a demo, we saw the way incident occurs, how do we respond, what are the automations done in it, and in terms of SRE, while we accept failure as normal behavior, and we want to make sure that we don't have the same failure happening into production system in exact same manner again, it's very crucial to kind of understand how incident response changes from the traditional system do when we do the shift to SRE, and what do we do post incident analysis, right? So we're all very familiar with the way we do the typical incident resolution, correct? We'll have a monitoring system, or we have a service desk team who will either catch the alert or who will catch the user complaint. They will pass it on to L1 engineer. They will do the SOP driven activity. They'll try to figure out what's going on with the system. And then there are different L2 groups where ticket gets passed on to it. L2 groups will perform additional troubleshooting, and if they are not able to resolve it, ticket goes on to the L3 resolver group. And between L3 resolver team, ticket will keep passing on between one group to another if they're not able to identify the problem and not able to fix the issue, right? And this is the traditional way of doing incident resolution, or is a traditional way of doing incident response. When we implement SRE practice, what will happen is the moment you classify a high severity incident in the organization or in the application or in the system, you engage different roles, right? So with SRE, there are different roles which get designated. You have incident commander, who would be IC, who would be responsible for owning the complete incident and governing the incident for the right resolution. And whenever there is an incident, we know that there are two stakeholders, one from the IT side of it and one from the business side of it, correct? Additional operations team, you may have additional developers team also who would be interested in knowing what happened with the application stack. So you kind of incident commander will communicate with two leads. One is the communication lead, who is responsible for sending out timely communication to the business users or to business people, or required stakeholders who are the service line owners or the application owner. And you have operations lead, who would kind of work closely with the team, ensure that teams are able to collaborate on a call, on a swamp call. The terminology which is used is the swamp. And in a swamp call, you will have all the users coming in and they start working on it. Correct. And ops lead will ensure that there is smooth collaboration, smooth communication, sending feedback back to the incident commander, and the communication lead is he or she would be part of the same call and catching the right update and sending it out communications to the other stakeholders, right, who are not your operations and development team members, because it's about translating your very technical terminology and understanding what's going on to a user-friendly or a non-technical language where people can understand what's the impact and when is it going to get resolved. I mean, this is the most prominent question anyone is going to ask, right? And what are we doing? Do we have right team on the call? Are we going on the right path? So that's how the whole communication and incident response works when we get into the SRE practices. Typically, when you look at the incident, what will we do? We have the outage, we have time to detect the outage, and this is where the monitoring tool would play a crucial role for you, because you want to know your monitoring system should be able to detect outage like as early as possible. So your all effort will go to reduce the time to detect, right? Then you have, once your alert is fired, acknowledge when team starts working in, you're looking at time to repair, right? So, and that's where you mitigate the issue, you bring the services back online. And that is the time to repair. So it's a time between the detection and the issue mitigation is your time to repair. And you want to reduce this as well as much as possible. And then the most important part you're doing is post-incident analysis. So once your issue is mitigated, you don't close it and you don't like kind of forget about it. You do the postmortem, you do the root cause analysis, and that will help you increase the time between the failures because you're able to proactively bring in some of the fixes into the system, right? And then life moves on, you have a next outage and you follow the same cycle if it happens, correct? So that's how typically the incident and incident response and the post-incident analysis would work in. It's very important to have a kind of different organization can use different templates. This is one what we feel very appropriate for the customers what we support. So it'll have like every incident, major incident where we are working. It'll have supporting document, which is a postmortem document, where you have the authors, the reviewers, who was the incident commander. You do the executive summary, which is more like a summary of the outage in a non-technical term. Then you have a problem summary, where you talk about what all issue happened during the incident. You put in the action items. Your action items will have the list of actions, you'll have list of owners, and you'll have the timeline, which is basically which action we are planning to complete by when. That is to basically improve the reliability of your system. And the last but not the least, very important section in the document would be lessons learned, right? I mean, that gets documented. So what went well, what didn't go as planned, what needs to be improved upon. And those are this whole 6 blocks would be part of the document. So, and get attached to the incident. So whenever we want to kind of refer to any specific incident and try and understand what happened, we can bring this back online. Now, if we, and that's how typical incident response and post-incident analysis would work in. The idea is to reduce the outage time. The idea is to reduce the ticket bouncing between multiple groups. And that's where we initiate the incident commander will initiate the call and all stakeholders jump in. If you go to the next slide, and that's more about the conclusion, right? How do you start SRE? And there are multiple steps to it, right? First, you focus on, we want to reduce the MTTR, which is mean time to repair. And we can do that by noise reduction. We want to reduce the deduplication. We want to do the deduplication, and we want to do correlation of the incident and identify the failure points. The step 2 would be when we are at step 1, if you see, we are not bringing in more value, business value, or we are not adding more values, but we are doing more of a cleansing. Then you automate the toil using your AI insight, using different analysis, and that is to reduce all manual activity. Like if you see, we did some of the automation using Selenium and a Python, where we are able to mimic the user behavior. And earlier, there was like kind of a daily check where engineer has to perform daily check, look at all the tile, click everywhere and understand everything is working fine or not. Now we are able to kind of automate that, and that manual activity is gone. Even during the incident, we used to follow the same step, which was done which was done by engineer, and now we have a kind of automation which will take care of it. So you are kind of reducing your toil or automating the toil. Then you pay down the technical depth for increased stability, which means if you had to add additional node, if you had to perform automated scale-up configuration, you perform that so that you are able to bring in the stability. Fourth step, which is subject by itself, and maybe in a subsequent, in following days, we may have a session completely on step 4, which is chaos engineering. This is a very important aspect of SRE, where we are able to do chaos engineering to kind of sanitize the system, to check our system on how stable they are, how robust they are, and if at all we have an impact, how we will be able to respond to it, how soon we'll be able to resolve it. And that will help us most accurately budget our error rate, right? And sorry. And post that, you get into the self-healing system. So this is a kind of a step-by-step process we need to kind of follow to get to the I wouldn't say the nirvana stage, but to get into the stage where we have self-healing systems and we are able to spend more time on the value-driven experimentations, right? And before we close this session, I mean, there are three questions I would like each one of you to ask yourself, and these are important whether you are starting your journey as an SRE or you are planning to implement SRE practices, right? The first question is, where are you in the SRE pyramid, correct? What are the skill set you own and or you have, and what skill set you want to kind of from where do we want to start on? The next is what layer you need to build and master on, right, to continue your reliability journey. And a last question, which is very important, should you automate everything? I mean, this is we spoke about automate toil, but you might not need to automate everything in the environment, because if the time you're spending to automate certain work is more than the time you will save, right? You don't want to automate that activity. So it's very crucial to look at this parameter also. And just to summarize all, right, if we say DevOps is the philosophy and SRE is prescriptive principles, then like in a term, class SRE implements the DevOps, right? I mean, that's how you summarize and conclude the session. I would like to thank every one of you to join us, spend time with us. You have spent precious evening, morning, afternoon with us. And I don't know if you have a time for the Q&A, but it was a pleasure to have you all. And hopefully we'll all connect soon on next topic.
Thank you so much, Jigar and Harshal. I think we are almost out of time, but we will find a way to email out the slides and further connect. If you could just move on to the next slide, Rahul, where we have the email IDs of all of us. I just want to encourage all of you to reach out to any of us for any of your questions, doubts, or if you have anything at all, if you have stumbled upon anything interesting. But we will look forward to hosting some of these webinars in the near future and look forward to connecting to you all. Thank you so much again.